All right, 4.5, angles of a polygon. Students will be able to classify polygons and find the sum and measure of the interior and exterior angles of polygons by completing an activity. Okay, polygon. This is simply a closed plane figure with at least 3 sides that are segments and their sides intersect at only their endpoints. It's basically just a fancy word for a shape, but it has to have straight lines as sides, no curves. A regular polygon, this is a polygon where all the sides and the angles have the same measure. So this one kind of looks like a regular polygon down here because they look like they're all the same size. A convex polygon, this is in drawing all the diagonals. There is not a diagonal outside the polygon. So for example, if I was to draw a diagonal, diagonals connecting any vertice to another vertice, any corner to another corner. I can't draw a diagonal here where it doesn't go outside of the, where it does go outside, sorry, all of them stay inside. However, here, the concave polygon, you could see you could draw a diagonal here from one corner to the other, and that line exists outside of the polygon. That's what makes this concave. So concave polygon, and drawing all the diagonals, there is at least one diagonal with points outside the polygon. Over here, I just have a list of shapes or polygons and their name based on the number of sides. So you got the quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, dodecagon. And n-gon just means when it gets really big, we might just say like, oh, you know what, it's a 63-gon. So we may not have a name for it, but we might just say a 63-gon. Just means a 63-sided polygon. For the most part, we're only going to be talking about convex polygons. We rarely are going to be talking about concave polygons. So the rules that we're learning today have to do with convex ones. And here's the deal. We've already learned that in a triangle, the angles add up to 180 degrees. So when you're dealing with a polygon, the real question is, how many triangles could you fit inside that polygon, only connecting vertices without overlapping? And you can see here, the pentagon with 5 sides fits 3 triangles. 3 sides fits 1 triangle, right? In fact, you could see 4 sides fits 2 triangles. And so this pattern emerges, and that is that if you take the number of sides minus 2, or n minus 2, that would tell you how many triangles fit inside each one. That matters because for every triangle, there's 180 degrees. And so you can multiply this by 180, and that will tell you the sum of all the interior angles in a triangle. It'll add up to the number of sides minus 2 times 180, and that's why. So, if that's true, we could find the sum of different polygons. For example, number 1, it says find the sum of measures of the interior angles of a hexagon. Well, a hexagon has 6 sides. So according to this formula then, the sum should equal 180 times 6 minus 2. So that means that we could fit 4 triangles inside a hexagon. And we could just do the math right there. 4 times 180 is 720. So the sum of all the angles would be 720 degrees. So I want you to use the same formula. See if you could find the sum of the measure of the interior angles of a heptagon. Use the chart up here to figure out how many sides a heptagon has. I would go ahead and try that on your own, and then pause the video, and you'll check your answer in just a second. Okay, so hopefully you saw a heptagon has 7 sides. So you do 180 times 7 minus 2, which is 180 times 5, which is 900. So the sum must be 900. Let's go on to the next page. Okay, slightly different question here. It says the measure of an interior angle of a regular polygon is 108. So now they're telling us what one of the angles is. It's 108. Find the number of sides in the polygon. Well, if we know that one of the angles is 108, isn't it fair to say that the sum would equal 108 times the number of sides, because the number of sides has to do with is going to be the same as the number of angles, right? 4 sides, 4 angles. 3 sides, 3 angles. 5 sides, 5 angles. So if we knew the number of sides, we could just multiply by 108 and that would be our sum. But we don't know the number of sides. However, we also know that the sum is always going to equal our little formula that we found, which is 180 times the number of triangles, which is n minus 2. Well, once you have these two expressions equal to each other, you can just solve this. Just solve for n, and that will give you the number of sides. So we have 108 n equals 180 n minus 360. We're going to subtract 180 n from both sides because we want all the n's on the same side. And we get negative 72n equals negative 360. Divide both sides by negative 72. And so you get n equals 5, right? And it has to equal 5. So that's because, remember, the negatives cancel each other out. And so that means this thing has 5 sides. That's the number of sides. All right, so I want you to use that as kind of a model, what I did here, to try practice number 2. Remember that I tried to come up with 2 expressions that I both knew equaled the sum and set those things equal to each other and solve for n. So go ahead and give that a try, and then pause the video and come back when you're ready to check your answer. All right, so I said 140 times the number of sides should equal the sum of the angles, and so should 180 times n minus 2. So I just used some algebra to solve this equation. I end up with n equals 9. Therefore, this polygon must have 9 sides. All right, let's try this problem. It says find the measure of each interior angle. Well, what do we know about this thing? We know that it has 4 sides. And so we could quickly find what all the angles add up to, right? We know that it's going to be 180 times n minus 2, or 4 minus 2, so that'd be 2. So it's going to add up to 360. And we also know that all of these should add up to 360. And we have 2, 4, 5, 6 x's total. And so we could divide by 6, and we get that x has to be 60. Well, if that's true, then we could just plug that in and we could say, hey, this is 120 degrees, this is 120 degrees, this is 60 degrees, this is 60 degrees. And we found the measure of each interior angle, right? We know what they all are. Let's try the next one. I want you guys to work this one out. Very similar problem. The only difference is this one had 4 sides and this one has 5. So I want you to try that one on your own. These are little right angle marks. That's what they're supposed to be anyway. So see if you can do that one on your own. Maybe pause the video and then check back in a few seconds. Okay, since this thing has 5 sides, 5 minus 2 is 3, so I'm going to multiply 3 times 180 to get 540. And at the same time, I know that I have 2 90 degrees, that's 180, plus 2, 3, 4, 5 x's, right? So I have a pretty simple equation here to solve. Subtract 180 from both sides, I get 360. Divide both sides by 5, I get 72. So x is 72, so therefore these angles are 72, 144, and 144. All right. Let's talk about the polygon exterior angle sum theorem. Here's what I want you guys to see first. Just draw you a picture. Let's say I had a triangle, and here's the exterior angles, right? And let's say I got that triangle really, really small. I know, it's like so small you can't even see it. Here would be the exterior angles still, right? Well, you can kind of start to see, what do you think all these angles are going to add up to? In fact, if I made that triangle so small that it was just a point, you can tell for sure what would the angles all add up to. It add up to 360. Well, that's true for triangles. Is it true for other shapes? Let's try a square or any just quadrilateral. Well, if I made that really small, in fact, made it so small that it was a point, yeah, still it's going to make one full rotation to be 360 degrees. In fact, this is going to be true with any shape that we draw. You could draw a dodecagon and make it infinitely small, and eventually you'd see that all the angles just go around in a complete circle, so it'd be 360 degrees. So the sum of the measures of the exterior angles of polygon, one at each vertex, is 360 degrees. Always going to be that way. So we can use that to solve this problem here. It says find the measures of an exterior angle and an interior angle of a convex regular octagon. Well, here's a convex regular octagon. If it's got 8 sides and has 8 angles, right? And all these exterior angles, we could draw one, right? Here's an exterior, 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 here's an exterior. All of those add up to 360. Well, if there's 8 of them, wouldn't it make sense that one, I'm going to call it E, exterior angle equals 360 divided by 8? And 360 divided by 8, I believe, is 45. Yeah, it's 45. So that means each one of these angles here is 45 degrees. So we found the one exterior angle, right? But, and all of these are going to be 45, by the way, right? All these exteriors are all the same because it's a regular octagon. So now they want one interior. Well, here's the deal. Isn't this an interior angle right here? And they're all going to be the same. And this isn't the only way you could solve it, but if you know that this angle right here is an interior and this is a straight line, you could just use the fact that these are supplementary to find the interior. So you could just say, hey, I know that 45 plus, I'll just put a little I here for interior, plus the interior angle have to equal 180. So subtract 45 from 180. And you get 135. So this angle would be 135 degrees. And there you go. That's the polygon exterior angle sum theorem. See you guys on the next video.